Hi folks, welcome to another exciting Math 2 video. Today we're going to be talking about mid-segments of a triangle. That's section 4.1 in our textbook. And hopefully you have some paper available to take some notes. If you don't, pause the video and get paper so you can take notes. So we're going to start with the mid-segment definition. A mid-segment of a triangle is a segment joining the midpoints of two sides of the triangle. So in my picture here, I have triangle ABC, and then I'm told that ED is the midsegment of triangle ABC. So based on the definition, that means that those two parts are congruent, and these two parts here are congruent, because E and D are the midpoints of those sides. Next, we have the midsegment theorem, which tells us that the midsegment of a triangle is both parallel and half the length of the third side. So in my picture here, similar situation, I have triangle ABC, I have ED, that's the midsegment. My markings here show me that E and D are midpoints of the sides. The midsegment theorem tells me that ED is parallel to BC, so that side is parallel to that side. And also, the length of ED is half the length of BC. So, two pieces of information on the midsegment theorem. So let's look at an example. We have a picture here where we're told that D, E, and F are all midpoints of the sides. So I have three different midsegments drawn here. So I know these are congruent, and these parts here are congruent. So the first question is DE, this side right here, is parallel to the side AC, the side that it doesn't touch. So we would say AC is the answer to that. FE, that's this side here, is then going to be parallel to this side, AB. If we know that AB is 21, so the length from A to B, this entire side, is 21 units long, then EF is going to be half its length based on the information from the midsegment theorem. So that is 21 over 2, or 10.5. If BE is 7, so now here we're told that BE is 7, then the entire length is 7 and 7, or 14. DF is going to be half that length, or 7. If DE is 10.2, so 10.2, then we're looking for the length of A to C. That's going to be twice that, or 20.4. Another example, we have triangle QRS, and we're told that T, U, and B are all midpoints. So again, we're dealing with midsegments. What is the length of TU, UB, and QR? So TU is parallel and half the length of the side it doesn't touch here, RS, so it's going to be half. So if RS is 40, then the distance from T to U is going to be half of that, or 20. UB goes from here to here. It is half the length of QS, so UB is going to be half of 50, or 25. And QR, this entire length here, is going to be twice the length of the midsegment 30 here that it doesn't touch. So the distance from Q to R is going to be 60. And then another example, in our situation here we have triangle MNO, and both all X, Y, and Z are midpoints. So again, we're dealing with midsegments. We are told that YZ is 2x plus 3. So from Y to Z, this is 2x plus 3. And we're told that MN is, that length there is 5x minus 14. and we're trying to find the length from y to z. So we're going to have to set up an equation here. We know that the yz side is going to be half of the mn side. So the most efficient way of setting this up is going to be 2 of the yz's, 2x plus 3, equals the mn side, 5x minus 14. So I need to solve this equation for x. I distribute the 2. 4x plus 6 equals 5x minus 14. Let's subtract 4x from both sides. Add 14 to both sides. Oops, it's 20. So if x is 20, we're trying to find yz. So I need to take that 20 and put it in for x in my yz expression. So 2 times 20 now plus 3 equals 43. And then another question, same situation. Let me get a different color here. Here we have yx is 3x minus 4. So this length here is 3x minus 4. And MO, this side over here, is 9x minus 20. Well, it's going to take 2 of these short guys to equal one of these longer guys. And then once we find our variable x, we're going to plug it in to find MO. So 2 times 3x minus 4 is going to be equal to 9x minus 20. Let's distribute the 2. 6x minus 8 equals 9x minus 4. Subtract 3x from both sides. 6x from both sides to get 3x. We're going to add 4 to both sides. Divide by 3. And x is negative 4 thirds. So we're going to take that negative 4 thirds. We're going to plug it in here and find the distance from M to O. So 9 times negative 4 thirds minus 20. 9 times 4 is negative 36 over 3 minus 20. That's negative 12 minus 20, or negative 32. Hopefully that makes sense. Make sure that you ask your teacher lots of questions. Thanks for listening.